Hi, welcome to this video. In today's video I'm going to do this problem. The question, let x equal to sum of cosine degree n goes from 1 to 44 over the sum of sine of degree n it goes from 1 to 44. Okay, what is the greatest integer that does not exceed 100x? Okay, this is from EMI 1997 EMI. This is American mathematical competition. Okay, go ahead and pause this video, give a try to this problem, and keep watching to see how to solve this problem. Okay, let's start working on this problem now. So we have x equal to the sum of cosine n from goes from 1 to 44, okay, over the sum of sine of n goes from 1 to 44. Okay, I'm going to distribute this one, put it on this form, and put it cosine 1 plus cosine 2 plus cosine 3 and so on until you get the last term, cosine 42 plus cosine 43 plus cosine 44, okay, over the sine of 1 plus sine of 2 plus sine of 3 and so on until you get the last the sine of 42 plus sine 43 plus sine of 44. Okay, so x equal to this one. I can switch these terms. I put cosine 44 in the front and keep writing all other terms in order, okay, until you get the first term. So let's put cosine 44 plus cosine 43 and so on until you get the last term, which is cosine of 2 plus cosine of 1. The same thing with sine. I can switch all these terms. I put sine 44 in front, so the sine, for the sine I can leave all these terms as they are. Okay, I can put these sine terms as they are. Okay, so the sine 1 is written on this form. So I have the same term that I have here, just I flip these terms. Okay, I'm just switching these terms, put the last term in the first term, okay, in order. Okay, so now cosine 44 equal to, I can switch this one to another number. I can write it on this form. So cosine 44 is cosine 45 minus 1. The second term, I can put it cosine 45 minus 2. And then until you get the last term, cosine 45 minus 43 plus cosine 45 minus 44. Okay, for the sine I can leave the numbers as they are. Okay, so sine 1, so if you take a look at here, cosine x plus sine x, I have cosine x plus sine x equal to square root of 2 multiplied by square root of 2 over 2 cosine x plus square root of 2 over 2 sine x. Okay, I'm just taking the square root of 2 out of the whole thing. I'm just taking square root 2 outside as a multiplier and put two terms inside, put square 2 over 2. If you distribute this one, it's giving you square root 2 multiplied by square root 2 over 2 is equal to 1, okay? So as I did nothing, so plus second term, but I'm going to arrive to another form, that's why I'm doing this one, okay? I'm going to transfer this form into another form, that's why I'm doing this one. So this cosine of 45 degree, okay? Multiplied by cosine x, or is square root 2 over 2. I can rewrite it sine of 45 degree, okay? Sine 45 degree equal to cosine 45 degree because they are equal to each other, okay? So that means sine 45 degree multiplied by sine x. This one equal to square root 2 multiplied by cosine, what is this? We have cosine A multiplied by cosine B plus sine A multiplied by sine B equal to cosine A minus B. Okay, so let's make cosine of 45 degree minus x. This identity is very important. Now I'm going to apply this one in order to solve my problem. Okay. So now let's take this one at the top and continue with our problem. Since I found sine x plus cosine x equal to square root 2 multiplied by cosine 45 minus x, okay? This one equivalent cosine 45 minus x. I'm going to divide both terms by square root of 2, okay? So this one will become square root of 2 multiplied by sine x multiplied by plus cosine x, okay? Equal to cosine 45 minus 1 plus cosine 45 minus 2 plus cosine 45 minus 3 and so on until you get this term. Cosine of 45 minus 43 plus cosine of 45 minus 44, okay? Over sine. So I have this one. I will write this one on this form. I'm going to apply this one. I'm going to apply this formula that I proved here, okay? 45 minus x equal to 1 over square root of 2 sine of x plus cosine of x. By replacing x by number 1 in the first term, so this one x, if x equal to 1, equivalent cosine 45 minus 1 of 2 sine of 1 plus cosine of 1. X equal to 2, equivalent cosine of 45 minus 2 equal to 1 over square root of 2 sine of 2 plus cosine of 2. Okay, as you see it here, you see this term, I'm just replacing x with 1, with number 1. So if you take a look at here, you see cosine 45 minus 1, we have cosine 45 minus 1, okay, equal to this one. I'm going to replace this one in this one. Every term has the value, okay? So now, for the x equal to 43, okay, equivalent cosine 45 minus 43 equal to 1 over square root of 2 multiplied by sine of 43 plus cosine of 43. Let's move on to the last term, which is x equal to 44. Equivalent cosine of 45 minus 44 equal to 1 over square root of 2 sine of 44 plus cosine of 44. Okay, this one I'm going to replace every term in numerator by its value, which is this one. So cosine, you have cosine 45 minus 1 equal to 1 over square root 2 of sine 1 plus cosine 1. Every term we have to replace by this one. Let's move on to replace every term by this one. X, I'm going to take 1 over square root 2 outside of the whole thing as a multiplier, okay? So this one becomes 1 over square root of 2. So I'm going to put the sign on side, on the left hand side. I will take cosine terms. I'm going to write down the sine terms on the left hand side plus the cosine terms on the right hand side, okay? So what is this? This is x, for example. This is x, okay? For example, this is y. So I'm going to divide the numerator and denominator by x, okay? By this one. So this one is giving me 1 over square root of 2 multiplied by 1, because this one divided by this one, plus this term, which is cosine 1, this sum over sine 1 plus. So this one, put 1 over square root of 2. This is 1. What is this? This is what I'm looking for. It was sum of 44, okay? What is this? Is x. So the x equal to 1 over square root of 2 multiplied by 1 plus x. Okay? I'm going to find x now. I'm going to solve the equation. So the x equal this one, I'm multiplying this one by this one, so x square root of 2 equal to 1 plus x. I'm bringing x on one side, so I will have x square root of 2 minus 1 equal to 1, okay? So x equal to 1 over square root of 2 minus 1, okay? Now, I put this one at the top and continue with our problem. Now, I found this one, x multiplied by square root of 2 minus 1 equal to 1, okay? So this one equivalent over square root of 2 minus 1. I'm going to rationalize this one by conjugate, okay? So this one multiplying the numerator and denominator by square root of 2 plus 1 equal to square root of 2 plus 1 over 2 is 1. So this one equal to 2 minus 1, so which is 2 squared plus 1, okay, over 1, which is 1. So this one x equal to square root of 2 plus 1. But my question, what is the greatest integer that does not exceed 100x? Okay, I'm going to apply the floor here, okay? So that's mean the floor of 100x equal to 100 multiplied by this value, square root of 2 plus 1. This one is giving us 100. If you multiply this one by this one, which is floor of 100 square root of 2 plus 100, okay? So this one I can rewrite it as 100 multiplied by 1.41 something plus 100, okay? Which is 200, which is 241 comma something, okay? This one, to calculate the floor of the number, okay? If you have to calculate the floor of the number, if the x is fraction, okay? we put this one always the floor of the number strictly inferior than x. If you have integer, x is an integer, the floor of the integer, the number strictly inferior or equal to x. For example, the floor of 5.1 equal to 5, we are extracting just the integer number from this value, okay? The floor of 100x, which is 100 square root of 2 plus 100 equal to 241, okay? So I have done with this problem. This is a good place where I can stop. Thank you for watching. I will see you in next video. Bye.